Welcome to this video. We will introduce the pandas package, which is a package used for advanced data management operations in Python. So far we have used built-in Python data structures and functions to process data. Data structures such as lists, dictionaries, and operations such as list comprehensions are essential for processing data in Python. However, they have many shortcomings, and especially when the data becomes large and the operations becomes complicated. The pandas package is designed to provide a very easy to use and comprehensive set of operations in Python. You can think about pandas as a spreadsheet package in Python. It basically allows us to store the data very much like in a spreadsheet in a table and provide similar and comparable operations. There are two main essential data structures in pandas: the series data structure and the DataFrame data structure. The series data structure, you can think about it as one column in a spreadsheet. Let's take a look at this example here. First, I'm going to import pandas, and because I'm going to refer to the package many times, I'm going to give it an alias, which is usually PD. Next, I'm going to create a series from this set of numbers. I'm going to store the series in an object called data. Now, if I type in data, what I get in here, I get the series of the numbers listed here, but I also get something else. This column we see on the left-hand side is called the index. The index is a very essential feature in pandas. It basically allows us to access the values that I put in here, and we can access these values by their index, and we can also perform many selection and transformation operations using the index. This is something we will get back to in the next lectures. Now, it's important here to notice that we can access the values. Those are the values that we put in the series itself. And pandas gave us a default index which ranges from 0 to 3. So if we create a series using just a bunch of values, a list of values, we get what we call a range index. And that's basically a default index that goes from 0 to the length -1, which is 3 in this case. Now, with a series, we can access the data very much like in a list. So I can do data at 1, and that will give me the second element in the data. I can also slice data. If I do data from 1 to 3, I'm going to get a slice from 1 to 3, obviously exclusive here, very much like in a list. So when we don't provide an index, we get something which is very similar to a list. So one way to think about the series is a series or a list of values. Now, series is much more powerful than a list because it also allows us to pass in an index. In this example here, I'm creating a series from the same numbers, but I'm providing what we call an explicit index. In this case, I'm telling pandas that I want to index my data with the index A, B, C, D. And what we can see in here is that we've got the same values, but the index, instead of being 0 to 3, is A, B, C, D. And then we can access the data very much like what we've done above, but instead of passing a number, we can pass in an index, such as data B. This is really interesting because when we do something like this, data of E and data of B, it's kind of acting like a dictionary. So we can think, one way to think about the series is kind of a hybrid, a list and a dictionary. Of course, we can provide our own index, which can be numeric. And in this case, we get an index, which is kind of an integer index. If we do data.index here, we can see that our index is 2537. Now, if I do data at 5, in this case, I'm going to get 0.5. So pandas will defer to the explicit index rather than using what we call an implicit index that ranges from 0 to length -1. In this example here, I have a dictionary, and I am creating a series from a dictionary. Once again, you can see that the series acts very much like a dictionary in many ways. So in this case, my dictionary is associating each one of these states with the population, and then I'm creating a series here. Once I create a series, I can access the value associated with the index or the key in the lingo of Python dictionaries using the square bracket notation. However, it's much more powerful than a dictionary because I can also slice my series. So I can say, well, give me all of the values from Texas to Illinois in this case. And I'm getting a slice of the series. And notice here that I'm slicing on the index. This is something we cannot do in a dictionary. For instance, I can do population dictionary California if I wish to. That's perfectly fine. However, I cannot do something like this with a dictionary. This operation, a slicing operation, is not defined on a dictionary. So to summarize, the series data structure associates values with an index, and we can access the values using their index. And in a way, it looks like a list because these values are listed in a sequence. And we can access these values if we don't provide an index using their position and integer-based indexing. But it also, very much like a dictionary, allows us to provide an explicit index. And in this case, we can access the values using the explicit index that we have provided. Next, let's look at the DataFrame object. Now, if the series is one column of data, the DataFrame is basically like a spreadsheet. It's a table of data. What I'm doing here, I'm creating another series. Let's call this series area, right? This is the area of these states. And I created a second series. Now I have two series so far, population and area. And what I am doing here, I'm creating a data frame. Now this data frame is created by putting two series together. And the first series will be under the heading population. The second series will be under the heading area. And what we get here, we get kind of like a tabular representation of the data frame. This is how the data frame shows in the notebook. That said, you have to understand that the state object is basically a data frame object, which allows us to access many of the functions associated with a data frame. Okay. So what is a data frame? Well, one way to think about the data frame is as a table, and this table has two indices. Well, obviously it has an index which is the same index of the series it's created from. So both of these two series have an index which is the name of the state, California, Texas to Illinois, and this index is kept here in the data frame. Now the data frame also has another index called the columns index. So the columns index is basically the column header of the data frame, which is in this case population and area. So we can think about the data frame as a two-dimensional data structure. Each value is determined by knowing the row index and the column index. So if I tell you population of Texas, you will know the value. If I tell you the area of Florida, you will know the value here immediately. So we can also re-access the initial series that were used to create the data frame. So if I do states square bracket area, this is going to give me the column area, which is basically the series area from the data frame. Similarly, if I do states population, I'm going to get the series population from the data frame. Now, we would like to talk a bit about the index object. The index object, which is used in the series and also used in the data frame. And again, don't forget the data frame has two indices, the row index and the column index, is an interesting object on its own. And as we will see in the future lectures, we can do some very kind of useful and powerful data operations by operating on the index. One way to think about the index is a set. So let's take a look at this index object here. I'm just creating an index that has these values 3, 5, 7, 11. We don't do that often. The index is often created when we create the data frame or the series. I'm just doing this for illustration purposes. So you can see here that the index itself is kind of like a list. All right, so we can get one value of the index, the second value in the index is 1, We can also slice it if I want to get each other value. So from the beginning to the end with a step of 2, I get another index. But another way to think about the index is we can think about it as a set. We have seen set operations in the past, and we can do set operations on the index. So say I have two indices here, index A and index B. I can do the intersection of index A and index B, the union of index A and index B, or the symmetric difference between index A and index B. So the index object itself is a hybrid. It's kind of like a list. It's an ordered list. It can also contain duplicate values. So I can do, for instance, 5, 5, 7, 11. I get duplicate values in the index. And it can also be looked at like a set. We can do set operations. Now don't forget that sets in Python do not support ordering. They also don't support duplicate values. So the index is kind of a chimera. It's kind of like a list in one way and a set in another way. In the next lectures, we will look at data indexing and selection in more details.